I'm going to be talking about lettuce, not the kind of lettuce you eat in a salad, but I'm going to be talking about the language called lettuce that we are going to design. And why is it called lettuce? Because it's going to use a lot of these things called the let binding. Okay, where was I? I was talking about lettuce. So lettuce is belongs to a family of languages called ML, family of languages. Okay, this is a fairly professional family. It has languages like SML, called the Standard ML NJ for New Jersey, the great state from which the language was designed at Princeton University. So they call it SML NJ. There's something called OCaml. Uh, there's something called F Sharp, which is our Microsoft approved .NET language. There is something called Reason ML, which is a Facebook style thing. There's something called Elm, which is a dialect of ML for programming. So for web programming, Facebook is also for web programming. It compiles to JavaScript and it talks to a lot of JavaScript libraries. So this is called the ML family of languages. And lettuce is this language that we are going to define and give life to that belongs to this ML family. Okay. How does a lettuce program look like? So let me dive deep and get you right to the concrete syntax. So the main thing in lettuce is going to be let bindings. Okay. And one way to think about it is I'm going to take our arithmetic. So last lecture, we did arithmetic. I'm going to start from arithmetic. To arithmetic, I'm going to add conditionals, conditional expressions. And to that, I'm going to add let bindings. So let me write some example programs in lettuce. And let's try and make sense of these programs in the concrete syntax. Concrete syntax. Okay, here we go. So the idea behind a lettuce program is you write let bindings. And let bindings look like this. So you say let x equals 10 in x plus 25. So this is an example of a very simple lettuce program with a let binding. So this let is a keyword in your language. It says, let me declare an identifier, x, let me assign it to the value 10, and use that in this expression, x plus 25. What should this program evaluate to? What do you think is a reasonable value this program should give you? 35. Thank you. Right? Makes sense, right? So you're assigning x to 10 and you're doing x plus 25. All right. And this is syntax directly coming from all these languages up here. All right. This is the same syntax. We are going to use this syntax. So now you can have interesting things, right? So what does its lettuce stand in? So there is a Scala equivalent for all of this. So in Scala, you would write the same thing as val x equals 10, and you'd say x plus 25. This expression, this entire thing is what is equivalent in lettuce is let x equals 10 in x plus 25. This is a semicolon. You don't need the semicolon. I'm just showing you that a semicolon can be written just to separate the two parts of the expression. Okay, and these are called let bindings. These are called let bindings. This is also called a let binding, even though there is no let there. This idea of declaring something and using it inside an expression is called a let binding. Okay, so if that is clear, let me try to use more and more kinds of expressions. So let's try one more. Let x equals 15 in let y equals 25 in x plus y. What should this program evaluate to? 40. Okay, does that make sense? And the way you read it is you have this part of the let binding, x equals 15 in this expression, in this sub expression. Let's call this E1. And then E1 itself is a let binding which says let y equals 25 in E2. So E1 telescopes into the entire big expression. Let's call it E. Okay, so what is happening is inside E you have E1, inside E1 you have E2. So this is E sub 1. Inside E sub 1 you have E sub 2. And this is how let bindings are going to be used. So you can define multiple things or you can declare multiple things this way. Okay, good so far. So let's do one more example. So let's say let x equals 10 greater than equal to 25 in if x then 15 else 45. So what does this program evaluate to? Okay, now you may need some help because you may not have seen something like this. But in Scala, you would write this as val x is 10 greater than equal to 25. And then you would say if x, you don't need a return. In Scala, you don't need a then either. Then is not used in Scala. You would say if x 15 else 45. So clearly, x is a Boolean. X is of type Boolean. And as a Boolean, it's very simple. Is 10 greater than 25? No, it's false. Yeah, people got it. People got it. As I was talking, people got it, right? So this is false. And then an if then else statement says if the condition here is false, then it evaluates to the else branch. And so the whole thing, the whole program evaluates to 45. Good so far? All right. Now let me write more programs. Let's write this program. Let x equals, and then I'm going to open a bracket so that you know how things are going. Let y equals 30 in y plus 10 in x plus 20. So let's take this example. So here you're let binding x to something. So let's call this expression here. Let's call this e sub 1, and let's call this expression e sub 2. Okay, so what does this program evaluate to? Well, then you say, okay, what does e sub 1 evaluate to? So what does e sub 1 evaluate to? 40, right? This whole e sub 1 evaluates to 40 because it's declaring y, assigning it to 30, and then doing y plus 10. So 40. And this whole thing is 40 plus 20 is 60. So e sub 2 evaluates to 60. So the whole program evaluates to 60. Good so far? So now you're getting something interesting, right? So what is happening in this is expression. So the entire programs are just expressions. So in functional languages, you have this. There is no hierarchy. So in an imperative language, you would have programs. A program is made of a bunch of functions, including a special function called the main function, which is the entry point. Well, functions are made of a bunch of declarations and statements. Statements can be made out of a bunch of while statements or for statements. You've seen this before, right? Or assignment statements or if statement or return statement. So you have this hierarchy in imperative programs. You have that program is a function, it's a bunch of functions. Each function is a bunch of declarations, a bunch of statements. Each statement is an if statement or a while statement or a block, which in turn has statements. You see that hierarchy where you grind down all the way down to an expression. And the poor expression is somewhere down, deep inside the hierarchy. In a functional program like Lettuce, if the only thing we talk about are expressions. The entire program is an expression. It is made in turn of expressions. All right. So here you have this entire thing. This entire blue blob is an expression. Inside it, you see expressions and expressions. And these are sub-expressions. And this x here is an expression by itself. So for example, you could write a Lettuce program that's just 20. And that's a valid Lettuce program. This is valid. It's just the expression, the naked expression 20 itself is fine. It's just an expression with nothing else surrounding it is fine, right? This is important to understand because it creates a lot of confusion. Then you're looking for where are for statements in Lettuce and where is while statements? No, Lettuce programs are going to have expressions and functions. We are going to be talking about functions in a bit. But what you will see is functions are themselves folded back into expressions. Everything becomes an expression. And that's how these programs operate. If there are no questions, let me get into the second bit of thing in Lattice. And this gets to a very important concept called scope. So when is a particular declaration in scope? So you might ask questions like, when is something in scope? And you'd have heard of this, right? People saying, oh, that went out of scope. That's not in scope, right? And so in programming, people talk knowingly about scopes all the time. So we have to formally understand what is a scope. And our understanding, hopefully, is a good understanding, because it's going to help us not just understand it for functional programs like Lattice, it's also going to help us understand other kinds of programming languages like Python, understand what is the scope and how does that operate. All right, with that being said, let me talk about let bindings formally. So a let binding in Lattice is of the form let identifier name equals expression in expression. Okay, and this is the concrete, this is how you think of concrete syntax of let bindings in Lattice. Okay, but remember, these expressions themselves may be let bindings. These expressions, sub-expressions themselves may be let bindings. Any questions about this so far? Okay, so then what is scope? So scope talks about, here you have ID name being declared and assigned to something. And let's call this expression 1, and let's call this expression 2. Okay, where is it legal to talk about ID name? Is it legal to talk about this ID name here in expression 1? Is it legal to talk about this ID name here in expression 2? And this idea of where can I talk about, where can I use a particular variable at a particular definition is called the scope of the definition. So when you say, what is the scope of ID name? You would say it is expression 2. Someone got it. You got it right. It is legal to talk about ID name in expression 2, but illegal to talk about it in expression 1. That's very, very simple. And when you write a wrong Lattice program, you know about that, right? So as an example, let's write a Lattice program that's actually wrong. So let's write this program. Let x equals x plus 10 in x plus 15. What's the value of x, right? And here you can see that there is a circularity, because when you're thinking about expression 1, x has not been defined yet. To define x, you need to finish evaluating expression 1. And then you get a value, like a number, you would assign that to x, and you can talk about it in expression 2. So this is legal. This is legal in scope. This is said to be out of scope, because the scope of x is exactly the box I have drawn. The red box I have drawn is the scope of this x. This x has a scope, which is this red box. Is that clear? Not this, not the, let me draw a different colored box, not the yellow box. That's not the scope of x. So x is not in scope here. X is in scope for the red box. That should be easy enough, right? When you look at a definition like this, it makes absolutely no sense. Everyone with me so far? If you're with me, then tell me what's wrong with this definition. Look at this program with a white box around it. Tell me what's wrong with this definition. Well, why has to be fully defined before it's referred to? Why is out of scope? Does not know what why is. Yeah, why is out of scope? So now you get to the second part of scope, which is things not only come into scope, things do go out of scope. Remember, like we are all actors on a stage and you come and go, right? All that Shakespeare stuff. Well, it's the same thing with scopes. Things come in scope and things do go out of scope. In this case, it turns out that the yellow box, the expression under the yellow box, defines the entire scope of y. Okay, so y comes into scope here and y goes out of scope here. Which means that when you come to this usage of y here, this is definitely out of scope. Is that okay? So what is the rule then? Then let us improve upon the rule. So an expression of this form, let identifier name equals defining expression 1 in use expression 2. Let's give some fancy names for this. Then where is ID name in scope? Yeah, so someone raised a beautiful point. I'm going to come to that in a second. So hold on to your question, Laura. So it comes in here, ID name comes into scope when you start looking at expression 2. When you're done with expression 2, it's out of scope. Okay, so that's the only portion where this particular ID name, this particular definition comes into scope. Is this kind of like local variables in a function? It is exactly like a local variable in a function, but now we are not in an imperative programming world. We are more in a world of functional programming. So you define scope more in terms of which expression is some other identifier in the scope. But it's exactly the same idea. When you translate this concept into Python or C++, that's exactly where you talk about scope. Okay, very good. So if you remember that things come into scope and out of scope, the conversation can now get to be a little bit more advanced. So let us now talk about a slightly more complicated program. So in this program, I'm going to say let y equals 10 in let x equals let y equals 20 in y times 2, let's say, in y plus x. So complicated. Now tell me, each of the definitions, here is point number 1, here is declaration let binding number 2, here is let binding number 3. Okay, so I have 3 let bindings going on in this program, and I've given them numbers 1, 2, and 3. And let me talk about usages. So here is usage number 1. Here is usage number 2. And here is usage number 3. Okay. So first of all, someone wants, let's answer what does this program compute. 40 plus 10, 50. Thank you. You got it. So someone posted to me saying, does this compute 50? Yes, it absolutely computes 50. Very good. All right. Now tell me, let's look at usage number 1. First of all, is it in scope? Okay. But now you see it's a slightly more subtle question. It's not like whether y is in scope, but there are 2 y's. There is the y at point number 1, and there is a y at point number 3. Which of them is in scope? Is usage number 1 mapped to definition 3 or definition 1? Definition 3. Very good. You see, it's so intuitive, right? So that's the mapping. What about usage number 2? Which definition does that map to? Definition number 1. Very good. See, there's an intuitive way of doing this, right? So do we have y equals 10 and x equals 40? That's exactly it. You do. And there is a name for what's happening here. And the name, and this is used in all languages. By the way, this is not letter specific. This y at definition number 3 is set to be shadowing this y at definition number 1. This happens in all programming languages. You would see this in Python, you would see this in C. So it's called shadowing. Yes, John's observation is absolutely correct. You have y equals 10, x equals 40. That's correct. And then let's talk about what the name for this is. This is called shadowing. So when I declare Y here in this scope with these white open braces and closed braces, this Y shadows an older definition. Okay, and in our version of Lattice, shadowing is allowed. Okay, so shadowing is definitely allowed, and you see this in all programming languages. So for example, in C or C++ or Python, you would see it. So in C, you could define int x, okay, in a global scope. And then you could say int function foo, let's say character pointer y, sorry, let's call it x. Why do we call it x? Because we love x and we are not very creative in the use of variable names. So we call it x. Well, this x here is a character pointer as far as the function foo is concerned. And what is it doing? It is shadowing the x in global scope. So this is shadowing right? And furthermore, if this is C++, you can do something more. You can open a curly brace. You can open a curly brace, and you can define a new block of code. In this new block, you can say, I don't know, void star x. Why do you do that? Because you love x and you are out of variable names other than x, so everything is an x to you. All right. I don't know. Some would say you have an X to grind. Apologize. Let's keep going. All right. So you can have these, right? And this is shadowing. So this X shadows, this void star X shadows character pointer X, shadows int X. And by the way, when you come out of this yellow open braces, closed braces, now you are in the scope for the character pointer. When you come out of this, you are now back in global scope. Okay, and we are going to study how this works. Okay, we'll study this in a little bit more detail using something called a scope chain. Okay, everyone good so far? Scopes, shadowing. So the question is not just about whether a variable is in scope, you can shadow. So when you shadow, your question more becomes like, not just whether y is in scope, but which y am I talking about? Which y did I define, right? So you could have this y with the green is one, the usage number one is actually definition number 3, right? On the other hand, this usage number 2 is definition number 1. Is that okay? So 3 concepts here. I've talked about scope. I talked about shadowing. So in scope, I talked about when does a particular declaration or a particular definition, when does it come into scope and when does it go out of scope? Every language has to have that definition. So things can be in global scope in some languages, but then you can shadow it. And you can shadow it by redeclaring it inside a function as a parameter or as a local variable or inside a block of code. And then suddenly you're in a new scope. So scopes, shadowing. Let me talk about the last concept, which is redefinition or redeclaration. Okay. So as an example, let's do this. Let x equals 10 in let x equals 20 in x plus 10. Okay. And the way this let binding goes is like this, right? So this x, this is expr1, and this is the, after the in is where it's expr2. So now you can ask, here is a usage of x, and here's 2 definitions of x. Which definition does this usage pertain to? $20, right? Usage number 2. Usage number 2 or usage number 1, right? You say usage number 2. And here what's happening is, in some ways you can think of it as shadowing, or you can think of it as a redefinition or a redeclaration. It depends on how you translate it into a different language. Like, for example, in Scala, you would have written the same code as val x equals 10, okay, val x equals 20, and x plus 10. Is Scala going to allow this? If someone has access to a Scala repo, try this out and tell me, is Scala allowing this for you? Nope, right? You do get an error, right? Some kind of a redeclaration or a redefinition. It shouldn't because they are vals, right? Yeah, exactly. So let me now pose a very strange puzzle for you. Those of you who are onto this, try this piece of code though. Try this val x equals 10. The semicolon is optional. Use it or don't use it. Open a curly brace and then do val x equals 20 and then do x plus 10. Do this for me. And for fun, just put a print line x at the end of this one, if you wish. Right? So Grigor says this is not allowed. The val x plus 10 is not allowed because they are vals. That's right, right? So in some sense, you can't redefine a val. What about this? What about this code right here? I know I'm going to confuse you, but this is where understanding of scopes and shadowing is going to help you a lot. Yes, so John says this X should print a 10, right? It prints 10, right? It accepts it, right? This didn't accept. So this did not compile. This works just fine. Why? Garbage collection, well, you're getting too much into like a concept. We don't need garbage collection to explain this. Laura is right, we shadowed. So here, when you opened a new curly brace in a language like Scala, it also happens in C++, by the way, this is a new scope. So what Scala does not allow you to do is redeclare a val. So Scala does not allow redeclarations in the same scope. So in the same scope is the operational point here. Redeclarations cannot happen in the same scope. But you're perfectly welcome to redeclare it in a new scope. So what happens here is you define a new scope when you open a curly brace. And in a new scope, you can shadow the older X. And yes, absolutely. So Logan says, won't Scala collect it after this? Yes, it does. Because now this older X, so let's call this X at 0.2, and let's call this X at 0.1. So here, 2 goes out of scope. So now scopes have this nesting property. It's almost like a stack. So when this curly brace is done, now this 1 comes back into scope. Well, it was always in scope. It's like a shadow came across it. Now the shadow is gone. Right? So yes, and Sean says it wouldn't let you redefine X even if you did it as a var. Yes, because that would become 2 declarations, right? You're declaring the same thing twice. It's like you come home and you say, honey, I'm home. Then you say, honey, I'm home. Well, whoever your spouse is going to be a little bit irritated, right? But if you said, honey, I'm home, open the door, close the door, come back and say, honey, I'm home, well, you declared a new scope, right? So the point is you can't redeclare, right? But you can open up a new scope and declare inside. But then inside this is a different X. It could have even been a different type. Scala would have allowed this to be a string or a Boolean. All right. So what do you think is happening with lettuce here? Is it more like this, case 1, or is it more like case 2? When you say let x equals 10 in, let x equals 10 in x plus 10. It depends. So now we get to the hard question, right? It depends on what you want to do. So if you say this is a case of shadowing and you treat it as such, it becomes a case like this. It becomes like this, case 2. So we allow it. Okay, and so we made this assumption that every time you start this in, if you redeclare X, this will shadow the old definition. Okay, so we made that. We could have said no, but that's not going to happen. Okay, so Jacob has a very good example. Let me write Jacob's example down. Thank you, Jacob. So val x equals 20 in x plus 10, and good. So what's going to happen? And let's just put a print line x. Try this out, right? So here x would actually be this x. So let's disambiguate. Let's call this x at 0.1. Let's give it a name so that we can talk about it. Let's call this definition 0.1. Let's call this declaration 2. Which declaration does the print line x correspond to? 1. Very good. Which declaration does this x plus 10, this x correspond to? 2. So you see, new scope, this x, it doesn't quite shadow. So this is not shadowing. Why is it not shadowing? Because remember, this x1 does not come into scope after this whole val thing is done. So, okay, it's just a new scope. You declare x, you undeclare x, and it already goes out of scope. So in our Lettuce language, this would look like this. Let x equals 20 in x plus 10 in blah, blah, blah. This is where your print would come. Okay, so here think of this open curly and close curly as Las Vegas, and X happened inside Las Vegas, so it stayed inside Las Vegas. Now that you're out of Las Vegas, you're back to your old X. That doesn't sound, just don't cut and paste that, and then don't tell me your professor is giving relationship advice, okay? But you see where I'm going. Scope starts, scope ends, things come in scope, things go out of scope. When you go out of scope, you go back to the old X. Okay? Is this working with everyone? Because now when we interpret Lettuce, we have to make this exact thing happen. And what you'll see is it magically just happens. As you will see, we can point out and say that it happens, but you will see that it happens. All right? Okay. Is everyone okay with scope? Is everyone good with it so far now? Okay. I hope you are. And if you have questions, you should definitely post.